June 5th, 1944, Portsmouth Harbor, England. Lieutenant Commander James Fisher stood on the concrete pier, watching the grey waters of the Solent churn with activity. Before him stretched a sight that would have seemed impossible just 3 years earlier. Row upon row of flat-bottomed vessels, each nearly 300 feet long, their bows yawning open like the mouths of mechanical whales. These were LSTs, landing ship tanks, and they were about to carry the largest amphibious invasion in human history across the English Channel to the beaches of Normandy. Fisher had spent the past 18 months commanding LST 325, one of over 1,000 such vessels built in American shipyards. He knew every rivet, every weld, every quirk of these strange ships that sailors had dubbed everything from large, slow targets to long, slow torture. But as he watched crews loading Sherman tanks, trucks, jeeps, artillery pieces, and mountains of supplies into the cavernous tank decks, he understood, something that few others grasped. These ungainly vessels, dismissed by naval architects as unseaworthy compromises, derided by traditional sailors as floating boxes, represented one of the most revolutionary warship designs in maritime history. Without them, Operation Overlord could not happen. The entire Allied strategy of landing massive armies directly onto hostile beaches, bypassing heavily defended ports, depended absolutely on having enough LSTs to carry the armoured vehicles and heavy equipment that modern armies required. And nearly all of these ships existed because one British naval constructor, despite opposition from his own Admiralty, had insisted on a design that almost everyone considered fundamentally flawed. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story began not in the shipyards of America or the planning rooms of London, but in the mind of a man who refused to accept that certain things were impossible. John Niedermair was a naval constructor in the British Admiralty's Department of Naval Construction. Born in 1889, he had spent his entire career designing warships, according to the established principles of naval architecture. Ships needed deep drafts for stability. They required proper hull forms for seaworthiness. They had to be built with structural integrity that could withstand the stresses of ocean travel. But in 1940, as German forces conquered France and the British Army evacuated from Dunkirk, Niedermair confronted a problem that traditional naval architecture couldn't solve. Britain would eventually need to return to the continent. That meant amphibious landings, and amphibious landings required ships that could carry tanks directly onto beaches. The problem was straightforward but seemingly insoluble. Tanks were heavy. A Sherman tank weighed 30 tons. A Churchill tank weighed nearly 40 tons. Any ship carrying dozens of these vehicles would need substantial displacement. But to land them on a beach, that ship would need to drive its bow directly onto the sand in shallow water, drop a ramp, and allow the tanks to drive off under their own power. This created contradictory requirements. A ship with enough displacement to carry multiple tanks would draw too much water to approach a beach. A ship with a shallow enough draft to beach itself would lack the hull form and stability to cross open ocean. And even if you somehow solved both problems, how would you build the bow? A conventional ship's bow was designed to cut through waves. It was pointed, reinforced, built to withstand the enormous forces of the sea pushing against it. But a beaching ship needed a bow that could open completely, providing a ramp wide enough for vehicles. The British Admiralty's initial attempts produced vessels like the Landing Craft Tank, or LCT. These were essentially large, landing craft, capable of carrying just 3 to 5 tanks. They had the shallow draft needed for beaching, but they were small, slow, and could only make short voyages in calm water. They couldn't cross the English Channel loaded with tanks if the weather turned rough. For the kinds of operations Britain would need to conduct, you would need hundreds of these craft. And even then, the limited capacity meant any invasion would take days to build up sufficient armoured strength ashore. Niedermair studied the problem from every angle. He examined the math. He reviewed the principles of naval architecture that he had learned over decades. And he reached a conclusion that would have made any traditional naval architect dismiss him as incompetent. The only solution was to build a ship that violated nearly every rule of proper ship design. It would need a flat bottom, eliminating the curved hull that provided stability and seaworthiness. It would need a square bow that could open completely, abandoning the pointed bow that enabled ships to handle rough seas. It would need ballast tanks that could be flooded to increase draft for ocean crossings, and then blown empty to reduce draft for beaching. It would need doors in the bow that could seal watertight for ocean travel but open to create a ramp, and it would need to be large enough to carry at least 20 tanks, while maintaining a draft shallow enough to beach. When Niedermair presented his preliminary designs in late 1940, the response was predictably negative. Senior naval architects pointed out everything wrong with his concept. The flat bottom would make the ship roll horribly in any kind of sea. The square bow would mean waves would slam into it rather than parting smoothly. The bow doors would be a constant source of leaks and structural weakness. The ballast system would be complex and prone to failure. The entire design was a compromise that sacrificed seaworthiness for beaching capability. But Niedermair had one powerful argument in his favour. Nothing else would work. You couldn't land a modern armoured division using only small landing craft. You needed ships that could carry substantial loads of heavy vehicles and deliver them directly onto a beach. If that meant building ships that traditional naval architects considered unseaworthy, then that was the price of conducting amphibious operations. He found an ally in Commodore Thomas Hussey, the director of the Inter-Service Training and Development Centre, who understood the military necessity, even if it offended naval sensibilities. Together, they pushed the concept forward, despite resistance from more conservative elements of the Admiralty. The first prototype was designated LST Mark I. The design specifications seemed modest on paper, but represented a revolutionary approach to ship construction. The vessel would measure approximately 280 feet in length with a beam of 60 feet. It would displace roughly 3,000 tons fully loaded. Most importantly, it would have a draft of just 3 feet forward when the ballast tanks were blown, allowing it to drive directly onto a beach. The flat bottom extended nearly the entire length of the ship. This created an enormous tank deck that could accommodate vehicles in a single level, making loading and unloading far more efficient than multi-deck designs. The bow consisted of massive hinged doors that, when closed, formed the ship's forward structure. When opened, they created a ramp that vehicles could drive down directly onto the beach. The propulsion system used twin screws, with the propellers placed in recesses to protect them when beaching. The engines were positioned aft to keep weight away from the bow, which would bear on the beach. Ballast tanks ran along both sides of the hull. When flooded for ocean crossings, they increased the draft to about 7 feet, providing better stability and reducing rolling. When blown empty, for beaching, they reduced draft to the minimum needed to approach shore. The British built 3 prototype LST Mark Is in 1941. The trials revealed exactly the problems that skeptics had predicted. The ships rolled heavily in any sea state. Crews reported that everything not tied down would slide from one side to the other as the vessel wallowed through even moderate swells. The flat bottom provided virtually no resistance to rolling motion. Seasickness was universal and severe. The square bow meant waves would slam into the ship rather than being deflected. In rough weather, green water would crash over the bow, flooding the well deck. The bow doors, despite careful sealing, leaked constantly. Pumps ran continuously to keep water out of the tank deck. The ships were slow, with a maximum speed of just 11 knots. Their handling was poor. They responded sluggishly to the helm. They took forever to answer rudder commands. They couldn't maneuver in restricted waters, with the precision that conventional ships achieved. And yet, they worked. When driven onto a beach, the bow doors opened, the ramp deployed, and tanks could drive directly off onto the sand. The ballast system, though complex, functioned as designed. The ships could carry their loads across the channel and deliver them where they were needed. But there was a critical problem. British shipyards couldn't build these vessels in the numbers required. Britain's shipbuilding capacity was already stretched to the breaking point. Building convoy escorts, warships to replace losses, and merchant vessels to carry supplies. The specialized facilities needed for traditional ship construction couldn't easily adapt to building these flat-bottomed oddities. In late 1941, as America's entry into the war became increasingly likely, British planners realized they would need American industrial capacity to produce LSTs in meaningful numbers. The question was whether American shipyards could build these vessels, and whether American naval architects would accept a design that violated so many fundamental principles. The answer came from an unexpected source. The United States Maritime Commission, desperate to expand America's merchant fleet, had pioneered revolutionary construction techniques for building Liberty ships, cargo vessels assembled using prefabricated sections and welding rather than riveting. These methods dramatically reduced construction time and allowed shipyards without traditional shipbuilding expertise to produce vessels. John Niedermair's LST design, with its simple rectangular form and flat bottom, was actually ideal for this kind of construction. The hull could be built in sections by workers with minimal shipbuilding experience. The flat bottom eliminated the complex curved plating that required skilled workers. The straightforward design meant less time spent on engineering and more time on actual construction. In early 1942, British and American naval architects met to discuss LST production in the United States. The British brought Niedermair's plans. The Americans brought their experience with mass production techniques. What emerged was a refined design, designated LST Mark II, that incorporated American suggestions while maintaining Niedermair's fundamental concepts. The American version lengthened the hull to 328 feet, increasing capacity. The beam widened to 50 feet. Displacement increased to over 4,000 tons fully loaded. The tank deck could now accommodate 20 Sherman tanks or 33 smaller vehicles, or equivalent cargo tonnage. The vessel could carry over 200 troops in addition to the crew of approximately 100 men. The design retained the flat bottom, the square bow with hinged doors, and the ballast system. But American engineers added improvements based on their experience with rapid construction. They simplified systems where possible. They specified materials that were readily available in American supply chains. They designed the ship so that multiple sections could be built simultaneously in different locations and then brought together for final assembly. The propulsion system used General Motors diesel engines, the same type being mass-produced for other military vessels. This standardization meant parts and maintenance expertise would be widely available. The twin screws provided redundancy, allowing the ship to continue operating even if one engine failed. Defensive armament was modest but adequate. The ships carried a single 3-inch gun on the stern for engaging shore targets and surface threats. Multiple 20mm and 40mm anti-aircraft guns provided defense against air attack. The LST wasn't designed to fight its way onto a beach. It was designed to land vehicles after the initial assault had secured the area. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The production program that followed represented one of the great industrial achievements of World War II. The United States designated multiple shipyards for LST construction, focusing on facilities along rivers and inland waterways where the shallow draft made these vessels ideal. Unlike deep-water warships that needed oceanside facilities, LSTs could be built in Pittsburgh, Evansville, and other inland locations, then sailed down rivers to reach the ocean. The first American-built LST, designated LST-1, was commissioned in December 1942. Production rapidly accelerated. Shipyards applied assembly line techniques. Hulls were built in sections. Engines were installed as complete units. Interior fittings were standardized. Workers specialized in specific tasks rather than building entire ships from start to finish. By mid-1943, American shipyards were flawed, completing LSTs at a rate that would have seemed impossible just a year earlier. Some yards delivered a completed vessel every 2 weeks. The total production would eventually reach over 1,000 ships, with the vast majority built in the United States between 1942 and 1945. But the question remained: Would these ships actually work in combat conditions? The first major test came in July 1943 during Operation Husky, the invasion of Sicily. Over 200 LSTs participated, delivering British and American armor directly onto the beaches. The operation revealed both the capabilities and the limitations of Niedermair's design. The good news was overwhelming. The LSTs performed their primary mission flawlessly. They crossed the Mediterranean loaded with tanks and vehicles, beached themselves on hostile shores, discharged their cargoes, and returned for more loads. The ability to deliver heavy armor directly onto beaches transformed. Amphibious operations. Commanders no longer needed to capture a port before they could bring tanks ashore. They could land complete armored divisions over open beaches. The bad news was that every predicted problem manifested in full measure. The ships rolled horribly in Mediterranean swells. Crews and troops were universally seasick. One crew member later recalled that walking across the tank deck during a crossing was like trying to walk on a floor that tilted 45 degrees one way, then 45 degrees the other, over and over. Anything not secured would slide across the deck, crash into the opposite bulkhead, then slide back. The bow doors leaked, as expected. Pumps ran constantly. The square bow meant that waves would crash over the front of the ship, flooding the forward areas. In rough weather, water would pour into the tank deck every time the bow plunged into a wave. The ships were slow and unmaneuverable. 11 knots maximum speed meant crossings took far longer than anyone wanted. Poor handling made them difficult to control in coastal waters with strong currents, and they were vulnerable. The flat bottom and thin armour made them easy targets for aircraft and coastal artillery. Several LSTs were sunk or damaged during the Sicily operation. The large, slow target nickname proved grimly accurate, but despite all these problems, the operation succeeded. The Allies established beachheads, landed their armour, and conquered Sicily. The LSTs made it possible. Traditional naval architects might consider them unseaworthy abominations, but they accomplished what no conventional ship could achieve. The lessons from Sicily led to modifications and improvements, but the fundamental design remained unchanged because the fundamental requirements remained unchanged. You needed ships that could cross open water carrying heavy vehicles and then beach themselves to discharge those vehicles. Nothing else could do both. If that meant accepting ships that rolled terribly, leaked constantly, and made everyone aboard miserable, then that was simply the cost of modern amphibious warfare. The next major test came in September 1943 at Salerno, Italy. Here, LSTs proved their worth in a different way. When German counterattacks threatened to push Allied forces back into the sea, LSTs made emergency runs to deliver tank reinforcements directly to the threatened sectors. Their ability to beach anywhere meant they could respond to tactical situations without waiting for port facilities or prepared landing areas. One LST commander, Lieutenant Robert Beeman, described the experience. "We came in under fire with 14 Sherman tanks aboard. German artillery had the range. Shells were hitting the water around us. We drove straight onto the beach, dropped the ramp, and those tanks rolled off and went directly into action. 20 minutes later, we were backing off to get another load. That's what these ships were built to do, and by God, they did it." The Italian campaign consumed LSTs at a steady rate. Some were sunk by air attack, others were damaged by coastal artillery. A few were lost to mines or simply broke down from the constant stress of beaching operations. But American shipyards kept producing replacements faster than the Axis could sink them. By early 1944, the Allied inventory of LSTs had grown to over 1,000 vessels despite combat losses. This massive fleet made possible planning on a scale previously unimaginable. When Allied commanders began seriously planning Operation Overlord, the invasion of Normandy, they assumed from the beginning that LSTs would be available in whatever numbers they needed. The entire operational concept depended on having enough LSTs to land multiple armoured divisions directly onto French beaches. The planning documents reveal just how central LSTs had become to Allied strategy. Of the approximately 7,000 vessels allocated to Operation Overlord, over 236 were LSTs. These ships would carry the Sherman tanks of American and British armoured divisions, the self-propelled artillery that would provide fire support, the trucks and jeeps needed for mobility, the engineering equipment required to build temporary ports, and thousands of tons of supplies. But there was a problem that few outside the highest levels of command fully appreciated. The number of LSTs was finite. Each ship could make only so many trips. Each beaching stressed the hull structure. Each crossing in rough weather increased the likelihood of mechanical failures. The planning staff needed to calculate precisely how many LSTs would be available, how many trips each could make, and how to sequence the landing operations to maximize efficiency. The logistics were staggering. Each LST could carry roughly 20 tanks or equivalent cargo. To land the armour for just one armoured division required multiple LST trips. To land multiple divisions required hundreds of LST trips. And all of this had to happen in the first few days of the invasion, before German reinforcements could arrive in strength. The planners calculated that they would need every available LST concentrated in England for the Normandy operation. Ships were pulled from the Mediterranean, despite protests from commanders there who were still fighting in Italy. LSTs in the Pacific were retained there because bringing them to Europe would take too long. The invasion date itself was partially determined by tidal conditions and by when enough LSTs would be available and ready. Lieutenant Commander Fisher, standing on the Portsmouth pier that June evening in 1944, understood none of this grand strategy. He knew only that his ship, LST 325, was loaded with 15 Sherman tanks, 6 jeeps, 8 trucks, and approximately 30 tons of ammunition and supplies. He knew that at dawn, they would cross the channel as part of the largest armada in history, and he knew that when they reached the French coast, they would drive their bow onto the beach, drop the ramp, and discharge their cargo under whatever conditions awaited them. The crossing began in darkness. Over 5,000 ships moved simultaneously, following carefully planned routes through minefields that had been swept clear days earlier. The LST formations travelled slowly, limited by their maximum speed of 11 knots. Faster warships and transports passed them, but the LSTs maintained their steady pace, carrying their precious cargoes of armour. The weather was marginal. General Eisenhower had delayed the invasion by 24 hours due to storms in the Channel, then made the crucial decision to proceed despite conditions that were barely acceptable. For the LST crews and the soldiers aboard, this meant a miserable crossing. The flat-bottomed ships rolled heavily in the 6-foot seas. Everyone not actively working was seasick. The tank decks became chambers of misery, with troops vomiting, unable to eat, simply trying to endure until they reached France. Fisher remained on the bridge, watching the dark shapes of other ships around them, praying that everyone maintained proper station. In darkness, in heavy seas, with hundreds of vessels in close proximity, the risk of collision was constant. The LSTs, with their poor maneuverability, were particularly vulnerable. They couldn't dodge quickly if another ship appeared too close. Dawn broke grey and cold. Fisher could now see the full scale of the invasion fleet. Ships stretched to every horizon. Warships, transports, landing craft of every type, cargo vessels, escorts, minesweepers, all converging on the French coast, and among them the ungainly LSTs, low in the water, flat-bottomed, looking like floating warehouses compared to the sleek destroyers and cruisers, but carrying the armour that would determine whether the invasion succeeded or failed. The beaches had been assigned code names: Utah and Omaha for the Americans, Gold, Juno, and Sword for the British and Canadians. The LSTs were assigned to specific beaches based on which units needed their cargoes. Fisher's LST 325 was headed for Omaha Beach, where the 1st and 29th Infantry Divisions were scheduled to land in the initial assault waves. The plan called for the infantry to secure the beachhead first, then the LSTs would come in behind them to discharge armour and vehicles. But as Fisher's ship approached the French coast around midday on June 6th, it became clear that the plan had gone catastrophically wrong at Omaha Beach. The beach should have been secured by mid-morning. Instead, Fisher could see through binoculars that fighting was still raging. The beach was covered with disabled vehicles, casualties, and troops pinned down by German fire from the bluffs overlooking the landing area. Smoke from burning vehicles obscured visibility. Artillery fire continued to impact in the surf zone. The LST formation received orders to hold offshore until the situation clarified. For 6 hours, they waited while the infantry fought to break through German defences. Fisher watched helplessly as the battle raged, knowing that the tanks in his ship's hold were desperately needed ashore, but unable to deliver them until the beach was secure enough for LSTs to beach. Finally, around 1800 hours, the breakthrough came. American infantry, through sheer courage and determination, had fought their way off the beach and secured the bluffs. The way was clear for the LSTs to approach. Fisher received the signal to proceed to beach. LST 325 turned toward shore. Fisher could see the devastation as they approached. Wrecked landing craft littered the shallows. Bodies floated in the surf. Burning vehicles smoked on the sand. Shell craters pocked the beach. And through all of this, his ship drove forward, propellers churning in the shallow water, bow aimed directly at the beach. The keel touched sand. Fisher ordered the ballast tanks blown. The ship settled lower, firmly grounded. The bow doors opened with a grinding of machinery. The ramp deployed, splashing into knee-deep water at the bottom. And then the tanks started moving. One by one, the Shermans fired up their engines, rumbled forward through the tank deck, onto the ramp, and down into the water. Their waterproofing held. They churned through the surf, climbed onto the beach, and immediately headed inland toward the sound of continued fighting. The entire process took less than 40 minutes. 15 tanks, 6 jeeps, 8 trucks, all discharged and moving toward combat. Fisher ordered the engines reversed. LST 325 backed off the beach, propellers pulling them into deeper water. They spun around and headed back toward England to load another cargo. Behind them, other LSTs were beaching, discharging their own loads of armour and vehicles. The steady flow of reinforcements and supplies that would sustain the Normandy campaign had begun. Over the following days and weeks, LSTs made trip after trip across the Channel. The statistics became numbing in their scale. During the first 48 hours of Operation Overlord, LSTs landed approximately 4,000 vehicles on the Normandy beaches. By the end of June, they had delivered over 21,000 vehicles and over 100,000 tons of supplies. At Utah Beach, where the landings had gone more smoothly, LSTs began discharging cargo within hours of the initial assault. The 4th Infantry Division's armour rolled off LSTs and pushed inland rapidly, linking up with airborne forces and establishing a solid lodgement. The steady flow of vehicles and supplies from LSTs enabled the Americans to expand their beachhead quickly. At the British and Canadian beaches, Gold, Juno and Sword, the pattern repeated. LSTs delivered the armour of British divisions, the specialised engineering vehicles that would clear obstacles and build temporary ports, and the mountains of ammunition and fuel required to sustain offensive operations. The British had developed specialised armoured vehicles for the invasion, including tanks equipped with flails to clear minefields, tanks carrying bridges, and tanks equipped with flamethrowers. All of these specialised vehicles came ashore from LSTs. The importance of LSTs became even more apparent when storms struck the Channel in mid-June. On June 19th, the worst storm in decades roared through the Channel, destroying one of the 2 artificial mulberry harbours that had been built to handle cargo. The mulberry at Omaha Beach was completely wrecked. For several days, virtually all supplies had to come across the beaches. This was exactly the situation that LSTs were designed for. While conventional cargo ships needed port facilities to unload, LSTs simply drove onto the beach, discharged their cargoes, and departed. The storm delayed operations and caused immense difficulties, but it didn't stop the flow of supplies, largely because LSTs could operate regardless of port facilities. One British officer, Major Hugh Bone, observed the operations and later wrote, "The Americans had developed this extraordinary class of ship that simply ignored all the traditional requirements of the seafaring trade. They couldn't sail properly. They rolled like pigs. Everyone aboard was constantly seasick, but they could put a tank on a beach anywhere in the world, and that single capability was worth more than all the elegant seamanship in the Royal Navy. The campaign in Normandy consumed LSTs at a steady rate, though less severely than some planners had feared. Some were damaged by mines, a few were lost to air attack, though by June 1944, Allied air superiority over the Channel was nearly absolute. Several broke down from the constant stress of beaching and required major repairs, but the vast majority simply kept operating, trip after trip, day after day, delivering the supplies that sustained the Allied advance. By late August, Allied forces had broken out of Normandy and were racing across France. Patton's Third Army advanced so rapidly that supply lines stretched to the breaking point. The railroads had been systematically destroyed before D-Day to prevent German reinforcements from reaching Normandy, but this meant they weren't available to supply Allied forces either. The Red Ball Express, the famous truck convoy system, carried supplies from Normandy to the advancing armies, but even that wasn't enough. LSTs adapted to new roles. Some were used to transport supplies directly to ports that had been captured along the French coast. Cherbourg, Street, Marlow, and other ports were wrecked and couldn't handle conventional cargo ships, but LSTs could beach next to port facilities and discharge directly onto the docks. Others made runs to Britain to pick up supplies and deliver them to the nearest accessible beach. The versatility of the LST design, which traditional naval architects had criticized as making the ships good at nothing, actually made them useful in many situations. They could carry virtually any cargo that would fit in the tank deck. They could beach anywhere with a suitable gradient. They could operate in ports, rivers, or open beaches. This flexibility meant that as the campaign evolved and requirements changed, LSTs adapted. In September 1944, LSTs participated in Operation Market Garden, the airborne operation aimed at capturing bridges in Holland. While the operation is remembered for the airborne assault, LSTs played a crucial role in delivering the ground forces that were supposed to link up with the paratroopers. The operation ultimately failed, but the LSTs performed their assigned tasks successfully. Then came the Scheldt Estuary campaign, the brutal battle to open the port of Antwerp. LSTs delivered the Canadian forces that fought through flooded polders to clear German positions. The ability to operate in shallow, confined waters proved crucial in this amphibious operation, conducted in rivers and estuaries rather than on ocean beaches. By the end of 1944, as Allied armies closed on the German border, the intensity of LST operations decreased. The major ports were now open and operational. Supply lines had been reorganized. The desperate improvisation of the Normandy period gave way to more organized logistics, but LSTs remained essential. They carried supplies to ports. They served as floating warehouses. They moved equipment between theatres as priorities shifted. The statistics of LST contributions to Operation Overlord and the subsequent campaign in northwest Europe are staggering but also difficult to quantify precisely. Various sources estimate that LSTs delivered between 40 and 50% of all vehicles that came ashore in the first months of the campaign. They carried roughly 30 to 40% of all supplies during the critical June to August period, when the beachhead was being consolidated and expanded. Without LSTs, the Allied build-up in Normandy would have taken far longer. Infantry divisions could have landed from conventional transports using smaller landing craft, but armoured divisions required LSTs to deliver their tanks, half-tracks, and vehicles. The speed with which Allied forces built up combat power in Normandy directly resulted from having sufficient LSTs to deliver armour quickly. John Niedermair, the British naval constructor who had designed the vessel that made all this possible, received relatively little recognition during the war. He was not a public figure. He didn't command ships or lead troops. He was a naval architect who had solved a technical problem. But the solution to that technical problem had enabled Allied strategy in both the European and Pacific theatres. In the Pacific, LSTs were equally crucial. The island-hopping campaign that brought American forces steadily closer to Japan depended absolutely on the ability to land armor on defended beaches. At Tarawa, Saipan, Guam, Peleliu, Iwo Jima, and Okinawa, LSTs delivered the tanks and artillery that enabled Marines and Army forces to overcome fanatical Japanese resistance. The design that naval architects had dismissed as unseaworthy had proven itself across every ocean and in every climate. LSTs operated in the freezing waters off Alaska, in the tropical heat of the Southwest Pacific, in the Mediterranean, in the Channel, and in rivers throughout Europe and Asia. They served until the end of the war and beyond. When the war ended in August 1945, the United States Navy had over 1,000 LSTs in commission. Production ceased immediately. The vast shipyards that had built these vessels turned to other work or simply closed. Many LSTs were decommissioned and mothballed. Some were sold to foreign navies, others were converted to civilian uses. But the fundamental design proved so successful that navies continued building similar vessels for decades. The LST concept, rejected by traditional naval architects in 1940, became a standard ship type in every major navy. Modern amphibious assault ships are direct descendants of Niedermair's original design, refined and improved, but based on the same fundamental principles. The human cost of operating these vessels is often overlooked in discussions of their technical capabilities and strategic importance. LST crews endured conditions that would have been considered unacceptable on conventional warships. The constant rolling made sleep difficult and seasickness universal. The crew quarters were cramped and poorly ventilated. The noise from the engines was deafening. And unlike sailors on cruisers or battleships who might go months without seeing combat, LST crews faced danger every time they approached a hostile shore. Seaman First Class Robert Matthews served aboard LST 507 and later described the experience. "You never got used to it. Every time we loaded up and headed out, you knew you'd be sick within an hour. The ship would start rolling and your stomach would start churning. By the time we reached the beach, you'd have been throwing up for hours, exhausted, dehydrated, and then you had to do your job while the ship was under fire. And then you'd turn around and do it again the next day." The casualty rates among LST crews were significant, though not as high as those of infantry units or submarine crews. The ships were large, slow targets that couldn't maneuver effectively to avoid attack. When hit by bombs, torpedoes, or artillery, the results were often catastrophic. The thin armor couldn't stop heavy weapons. The fuel and ammunition carried in the tank deck could explode. And the bow doors, essential for the ship's mission, were a structural weak point that could fail under battle damage. One of the worst disasters involving LSTs occurred during Exercise Tiger, a rehearsal for the Normandy invasion conducted in April 1944. German E-boats, fast attack craft, penetrated the exercise area and attacked the LST convoy with torpedoes. 3 LSTs were hit. LST 507 exploded and sank within 6 minutes, killing over 400 men. LST 531 also sank rapidly with heavy casualties. LST 289 was damaged, but survived. The total death toll exceeded 700 American soldiers and sailors. The disaster was kept secret to maintain security for the upcoming invasion. The survivors were sworn to silence. The bodies recovered were buried quietly. Families were told only that their loved ones had died in training accidents. The full story didn't emerge until decades after the war ended. But Exercise Tiger demonstrated the vulnerability of LSTs and the courage required of their crews who knew these ships could be sunk quickly if caught by enemy action. During the actual invasion, LST casualties were mercifully lower than feared, largely because Allied air and naval superiority prevented German surface ships and submarines from attacking the invasion fleet effectively. But individual LSTs were lost to mines, artillery fire, and air attack. Each loss meant not just a ship, but the crews who sailed them and the soldiers and cargo they carried. LST 523 struck a mine off Normandy on June 19th and sank. LST-314 was hit by German artillery while beached at Omaha Beach and burned for 3 days before being declared a total loss. LST-496 was damaged by a mine and had to be towed back to England. The list went on, each entry representing a ship destroyed or damaged, and men killed or wounded. But for every LST lost, American shipyards built replacements. The production system established in 1942 continued operating at high capacity throughout 1944. When planners calculated LST requirements for future operations, they simply assumed that losses would be replaced. This ability to absorb losses and continue operations was itself a form of strategic superiority. German and Japanese forces had no equivalent capability. When they lost ships, those losses were permanent. The design's influence extended beyond military applications. After the war, dozens of LSTs were converted to civilian use. Their large cargo capacity and ability to beach made them ideal for operations in areas without port facilities. LSTs served as ferries in the Philippines, cargo ships in the Caribbean, and supply vessels throughout the developing world. Some operated commercially until the 1980s, 40 years after they were built. The Greek Navy operated LSTs, acquired from the United States well into the 21st century. The ships were upgraded with modern electronics and engines, but the basic hull design remained Niedermair's original concept. The last of these vessels, the HS Chios, formerly USS LST 1123, was finally decommissioned in 2010, 66 years after it was built. One LST, the LST-325, survived not just the war but decades of subsequent service to become a museum ship. After serving in the United States Navy during World War II, it was transferred to the Greek Navy where it operated until 2000. A group of American veterans then purchased the ship, restored it to operational condition, and sailed it from Greece back to the United States in 2000. A voyage that proved the design's seaworthiness, despite everything critics had said 60 years earlier. The ship is now permanently moored in Evansville, Indiana, one of the cities where LSTs were built during the war. Visitors can tour the vessel, walk through the tank deck where Sherman tanks once sat, climb to the bridge where crews navigated through enemy fire, and gain some small appreciation for what it meant to serve aboard these ungainly but essential vessels. The technical legacy of the LST design influenced amphibious warfare for generations. Modern amphibious assault ships, vastly larger and more sophisticated than World War II LSTs, still use the same basic concept: a flat-bottomed hull that can beach, bow doors that open to discharge vehicles, and ballast systems to adjust draft. The United States Navy's modern dock landing ships and amphibious transport docks are direct descendants of Niedermair's original design. The strategic legacy is even more profound. The LST made possible a form of warfare that shaped the entire second half of the 20th century. The ability to project military power across oceans and land it on hostile shores without requiring captured ports fundamentally altered the strategic calculations of military planners. Nations that possessed large fleets of amphibious assault ships could threaten invasions anywhere along an enemy's coastline, forcing defenders to spread their forces thinly rather than concentrating them at likely invasion points. During the Cold War, the United States maintained large amphibious fleets specifically to preserve this capability. The Marine Corps organized around amphibious operations, with divisions designed to be landed from ships directly onto beaches. The threat of amphibious assault shaped Soviet defensive planning and forced them to defend thousands of miles of coastline. All of this stemmed ultimately from the technological breakthrough that Niedermair had achieved in 1940 when he designed a ship that could both cross oceans and beach itself. The human story behind the LST program reveals much about how wars are actually won. The popular imagination focuses on battles, on dramatic moments of courage under fire, on generals making crucial decisions. These things matter, certainly, but wars between industrial nations are ultimately decided by production capacity, by the ability to build weapons faster than the enemy can destroy them, and by the willingness to accept imperfect solutions that work rather than waiting for perfect solutions that might never come. John Niedermair's LST design was never perfect. It remained, until the end of its service life, a ship that rolled terribly, handled poorly, and made everyone aboard miserable. Naval architects never stopped criticizing its fundamental compromises. But it worked. It accomplished the mission. It could be built quickly and in large numbers. And it enabled operations that would have been impossible with more elegant but less practical designs. The workers in American shipyards who built over 1,000 LSTs between 1942 and 1945 were part of an industrial achievement that rivaled any military victory. Many were women, entering the workforce to replace men who had gone to war. Others were African Americans who found opportunities in war industries that had been denied them in peacetime. Some were older workers, past the age for military service but contributing their skills and experience. Together, they produced the ships that carried the Allied armies to victory. The crews who sailed these ships displayed a different kind of courage than infantry charging into enemy fire. They endured conditions that tested human endurance, seasickness that left them weak and dehydrated, constant danger from enemy action, and the knowledge that their ships were vulnerable targets that could sink quickly if hit. They did this not once but repeatedly, trip after trip, crossing and recrossing hostile waters to deliver the vehicles and supplies that kept the armies fighting. Lieutenant Commander Fisher, who had stood on the Portsmouth pier that June evening in 1944, made 43 round trips across the English Channel between D-Day and the end of September. Each trip meant 12 to 18 hours of rolling, pitching misery, followed by the tense moments of beaching under potential enemy fire, then the rush to discharge cargo and get off the beach before enemy artillery could target his stationary ship. He later wrote in his memoir, "I never loved that ship. Nobody loved LSTs. They were miserable to serve on. But I respected what they could do. I respected the engineers who designed them to solve a problem nobody else could solve. And I respected my crew who kept showing up, kept doing their jobs, kept taking that horrible ship back across the channel one more time, because the army needed what we carried." By the time the European War ended in May 1945, LSTs had carried the Allied armies from England to France, up through Italy, across the Rhine into Germany, and to a dozen smaller amphibious operations throughout the Mediterranean and Northern Europe. In the Pacific, they had island-hopped from Australia to the Philippines, from Pearl Harbor to Okinawa, delivering the tanks and artillery that enabled American forces to overcome Japanese defenses on fortified islands. The final accounting of LST contributions to Allied victory defies precise calculation. How do you measure the value of being able to land tanks directly on a beach instead of having to capture a port first? How do you quantify the strategic flexibility that came from being able to threaten amphibious landings anywhere along thousands of miles of coastline? How do you calculate the lives saved because armoured support could be landed quickly rather than leaving infantry to fight without tank support? What can be stated with certainty is that without LSTs, the Allied strategy in both theatres of war would have been fundamentally different. Operations that actually occurred would have been impossible. Invasions that succeeded might have failed. The war might have lasted longer and cost more lives. The ungainly, unseaworthy, uncomfortable LST, dismissed by traditional naval architects as a poor compromise, proved to be one of the most strategically important vessel types of the entire war. John Niedermair died in 1972, largely forgotten outside naval architecture circles. He never achieved the public recognition given to generals or admirals. No battleships were named after him. His obituaries were brief. But the ships he designed had carried the weight of Allied victory. They had landed the tanks that liberated Europe. They had delivered the armour that conquered the Pacific Islands. They had enabled a form of warfare that changed military history. General Eisenhower, in his memoir Crusade in Europe, wrote briefly about logistics and the tools that made victory possible. Among the weapons he considered essential, he listed the atomic bomb, the radar, the transport airplane, and the LST. He understood that wars are won not just by fighting, but by the ability to deliver fighting power where it's needed. the LST, more than almost any other single weapon system, gave the Allies that ability. On the beaches of Normandy today, visitors can still see the remains of the artificial harbours that were built after D-Day. They can visit the museums that display weapons and equipment. They can walk the sand where so many died. But the LSTs themselves are gone, scrapped or sunk or converted to other uses. Only a handful survive as museum ships, preserved examples of a vessel type that changed the world. Yet their legacy remains in every modern amphibious assault ship, in every military that maintains the capability to land forces on hostile shores, in every strategic calculation that considers amphibious operations as a viable option. The flat-bottomed, square-bowed, uncomfortable ship that John Niedermair designed in desperation in 1940, the ship that traditionalists dismissed as unseaworthy, proved seaworthy enough to cross every ocean and land on every hostile shore where the Allies needed to fight. 40% of all vehicles landed at Normandy in the crucial first weeks came ashore from LSTs. Thousands of Sherman tanks, tens of thousands of trucks and jeeps, mountains of supplies, all delivered directly onto French beaches by ships that weren't supposed to work but somehow did. That achievement, repeated thousands of times at dozens of landing sites across two oceans, stands as testament to the power of practical solutions over perfect theories, of determination over doubt, and of ungainly functionality over elegant uselessness. The next time you see photographs of D-Day, look past the dramatic images of infantry wading through surf under fire. Look instead at the ships in the background, the flat-bottomed vessels with their bows driven into the sand, their ramps deployed, tanks rolling out onto the beach. Those are LSTs. They're not beautiful, they're not elegant, but they're the ships that won the war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.